Alright, so my first question is number 2, which says an object is at rest and then experience some acceleration, and then it asks how far the object travels in 3 seconds. So I wrote out all the things you need to solve this problem. So it says you're at rest, so your initial velocity would be 0 meters per second. You don't know your final velocity though. It gave you acceleration, which is 2 meters per second squared. You're trying to find distance, and then it gave you time of 3 seconds. So if you go and look at your equations in your notes, you'll find that this equation gives you all the parts that you are given in this problem. So we just plug it into the equation. So put smiley face for your distance. Your initial velocity is 0. Time at 3 seconds plus 1/2 of your acceleration, which is 2. Times it by your time. Then you square it. And you just solve it. 0 times 3 is 3, or 0. Plus 1/2 of 2 is 1. Times 3 squared is 9. So this, you add nothing. 1 times 9 equals 9 meters, which is answer A. Moving on to question 18, which says an object is dropped from the rest of the top of a 400-meter cliff on Earth. There's no air resistance. What is the distance the object travels during the first 6 seconds of its fall? So just like problem 2, it's pretty much asking the same question, just with different numbers. So again, it starts from rest. So initial velocity is 0 meters per second. You don't know your final velocity. You do know your acceleration, which is -10, because that's what gravity is, or 9.8, but we're rounding it to 10. You're finding distance, which is a happy face, and then your time is 6 seconds. So again, we're going to use the same equation for this. So smiley face equals your initial velocity, which is 0, times your time, which is 6, plus 1/2 of your acceleration, -10, times your time, again, 6 seconds squared. And you just solve it again. 0 times 6 is 0, plus 1/2 of -10, which is -5, times 6 is 36. And then you just times -5 and 36, which equals 180. It's not negative because you can't move in a negative direction. So this is why it's positive. So you get on 180 meters, which would be answer D for question 18. Last question is 34. You have a graph that's given to you that looks like this. Time, distance. So it's multiple choice of 5. You have to take which says the best for this graph. So A said the car is moving with a constant non-zero acceleration. Yeah, that's not really giving enough information, I guess, about the graph. So it's not the best, but it's alright. And then B, the car isn't moving. Well, if it wasn't moving, there would be no line here, which means you wouldn't get anywhere in any time. C says the car is moving with a uniform increasing velocity. That does make sense. It is moving and has a velocity. D says the car is moving at a constant velocity, again, velocity. And the car is moving with a uniformly increasing acceleration. This is an acceleration graph because it's distance and time. Maybe if this was velocity and time, then you would be a acceleration graph, but it's not. So you can cross that one out too. So the two good answers are C and D right now. Again, C says the car is moving with a uniformly increasing velocity. So let's talk about this. I'm just gonna label this 1, 2, 3. All right. So this is a straight line. So at 1, 1, velocity equals distance over time, right? So 1, 1. Oh, that's a 2. This should be a 1. So velocity would be 1, right? Meters per second. Now let's go to 2, 2. 2 over 2. This is also 1. So your velocity isn't increasing as your distance in time is increasing. So C can't be right because it says it's increasing velocity while it's actually just being constant, which D says. So the answer is D for number 34.